Hello everyone, welcome to our webinar today, CBRS Applications Today and Tomorrow. Wish you a good afternoon. We're very fortunate to have a nice slate of speakers, including me, strangely enough. And so if we go to the next slide, I'll introduce who will be speaking to you. The first presenter, myself, Alan Ewing. I am the Executive Director of the CBRS Alliance. We are an industry association. I'll tell you a little bit more about the industry association, the CBRS Alliance, in my slides. But this is an industry association that all of our members have the common purpose and interest in bringing shared spectrum, utilizing LTE and the CBRS band into reality and into commercial viability. I'm very fortunate to be joined today by two very knowledgeable and very enjoyable people to speak with, who are also members of the CBRS Alliance and key members in their personal interactions in the Alliance. First is Mark Gibson, who is the Senior Director of Business Development and Regulatory Policy at CommScope. Mark is also a board member of CBRS Alliance, so we're very fortunate to have his leadership in all of this. And really, he has been one of the key technology developers in helping specify the mechanisms for spectrum sharing. He works with several of our sister organizations, including Wind Forum, and he sits on the Commerce Spectrum Management Advisory Committee. In many ways, I think of Mark as sort of a bit of the heart and soul of what we've done here. He's the spirit of a lot of the work that we've done. We're very fortunate to have him today to speak to us. Our other speaker, next slide, is Dr. Preston Marshall. And just as Mark is sort of the soul, if you like, of CBRS and what we've rolled out, I often think of Press as the intellect or the brain of CBRS, and also as the chair of the CBRS Alliance Board of Directors. He's the principal wireless architect for Google, and he's key in developing specifications. Really, he's the guy helping deliver the mechanisms, the rules, if you like, for making this all work. He's also a published author that we like to make sure we point out, but his involvement has been from the start, and his relationships with government, all the way, from his work at DARPA, et cetera, have really put him in a great position to have these, to be able to devise the spectrum sharing that we now call ONGO and in the CBRS band. Next slide. So a quick overview of our agenda, welcome introduction. We've already taken care of that. The what is ONGO and CBRS, I'll be taking you through there. What to look out for, the SAS and the Google perspective. So our speakers will address those. Next slide. So for me, I will give you a quick overview of the Alliance itself, a little bit of the structure, a little of the history. We can go on to the next slide. So here we have a timeline, and this timeline is really to represent the work that has been done and has been accelerating since early days. So 2010 is where the story begins. This is where the band was really specified and identified for potential sharing. FCC did the work in the background to propose the 3-tier framework for sharing in 2014. The Industry Association CBRS Alliance formed in mid-2016 to bring reality and LTE in particular to the band. And the launch of what the ONGO brand is in 2018, ONGO being CBRS band where LTE and eventually 5G and R are deployed. Then we did a lot of back work to get specifications developed for coexistence, network services, etc. Then in 2019, things began to coalesce into reality. And this is where the ESC networks were approved and deployed. The SAS, the spectrum allocation system testing, was really finalized, and the SASs were ready for commercialization. And in September 2019, the initial commercial deployments were launched for the band. The final work done to get us to full commercial deployment the rest of 2019, and at the beginning of 2020, There's the full commercial service launch for GAA. The other activities in 2020, of course, we are really enabling the 5GNR from a specification point of view. So we are ready as real equipment becomes available for deployment. The other big piece of news that will be discussed somewhat is the PAL auction, which just concluded, started in July 2020, and really just concluded. Next slide. So just a very quick view. This is a bit of an eye chart. It's not meant to be, but it's meant to be in the sense that we have a lot of members. We, as of today, have 182 member companies that have joined with us on this mission and on this journey. And it runs the gamut from large companies and easily recognizable names in the telecom and internet worlds, all the way through much smaller companies that do very specific parts of the ecosystem development for shared spectrum. So all of our member companies participate in some form or fashion in the activities of the Alliance. The idea here is we've created a community really to allow for all of these companies to reap the benefits of the band. Next slide. So here we have some information about this last year that's been so exciting for us here at CBRS Alliance, the inaugural year, where we have brought the technology online and made it available in initial and then full commercial deployments. So what you see here is a celebration that we hosted back in September of last year. It seems forever ago now, but in that we were very fortunate to have representatives from our government partners, FCC, Department of Defense, NTIA, etc., all talking with us and sharing with us the excitement of launching the band. In that time, since we've gone to full commercial deployment, there's literally been tens of thousands of CBSDs deployed in the field. These are the base stations in both what we call Category A and Category B. This is essentially indoor versus outdoor. There's all types of use cases from mobile broadband, fixed wireless, private use cases. It's really whatever the imagination can explore. These are the kinds of use cases we're really starting to see out there. From an ecosystem point of view, the ecosystem has been growing by leaps and bounds, and we're starting to see that logarithmic growth in most of our space of equipment. So right now, over 83 authorized models of CBSDs, well over 100 authorized client devices. That number has even gone up since our slides have been prepared. It seems to go up hourly almost. So that number covering all types of things like phones, data dongles, routers, specialty devices, IoT devices, etc. So that space is really getting quite exciting. There are 5 authorized SaaS admins, 2 of which are represented here, Google and CommScope, but 5 different authorized SaaS admins, more than 2,000 certified professional installers, a key element of how this works when we deploy the networks. And then finally, our pathway to 5G has been properly, the foundations of which have been properly laid. So we're very excited about this inaugural year in going from a system that wasn't launched to one that is launched and one that is growing an ecosystem very rapidly. Next slide. So here we have a slide where we talk about our relationship between the key organization, Wireless Innovation Forum, who acts as our standards development organization, and CBRS Alliance. Wireless Innovation Forum is a sister organization. We have a liaison relationship with them, and there are many members that are in both organizations, many key members, including our presenters today, and they have leadership roles in both sides. Really what Wireless Innovation Forum is there is the linkage to the FCC, the development of the specifications for approving the SaaS interaction with the CBSD, the codification of FCC Part 96, which we all know and love from our world, and how that links to CBRS Alliance is CBRS Alliance is really the industry association that's there to make sure that LTE and 5GNR, these are the technologies, of course, based on 3GPP standardization, are the ones utilized in the band. So that's our focus. Other technologies can be used in the band, but CBRS Alliance's focus is to bring LTE and 5G NR. Next slide. So here's just a very quick snapshot of this three-tiered spectrum sharing model. And what you see, if I start from the bottom, what we have here is what we call general authorized access. General authorized access is 150 megahertz of spectrum that is shared, can be used as long as neither of the two tiers above have essentially a claim on that particular portion of spectrum. So there are 15 channels. There are 10 megahertz channels here, 150 megahertz of spectrum. And the idea is that if it is not in use by one of the higher tiers, it's available and can be taken into use by whoever needs it, whoever has a CBSD set up in a proper configuration, has all of their SAS connections, et cetera, done. So the next step up is much in the news lately, our PAL, or Priority Access License tier. And this is an auction that just concluded. Essentially what the PAL did was auction off 7 10 megahertz licenses. This was done by county by county. And I know Mark has a lot more analysis on that, so I won't delve into that part. But the idea here is that if you purchase a PAL license, it gives you one step up in the prioritization over the GAA folks. That's not to say that you're going to kick somebody in GAA off. What it means is it's going to share the spectrum effectively, but the PAL will get first pick, if you like. Think of it like a traffic cop, making sure that the traffic is flowing and the PAL is just the priority in the traffic flow. Finally, the top tier are the incumbents. These are the ones that get it if they need it. And the main incumbent, of course, is the Department of Defense, military radars, ground-based, ship-based, also fixed satellite stations, receivers. And you notice here WISPs that are a different color. That's because the WISPs are evolving to working in our rules under Part 96. So that is an evolutionary step that is occurring even as we speak. Next slide. And so just wanted to touch on the fact that this has really been a collaboration, a public-private collaboration, government and industry working hand in hand, and working hand in hand in such a way as it's been viewed extremely positively. NTIA and the FCC both have had nothing but positive, nothing but a good experience here. We've tried to ensure that that's the case so that all of this was able to be delivered for the public, to have a way of sharing this spectrum that was being underutilized, and doing it in a way, though, that is respectful to the incumbents. And that's an area we've been successful. It's one thing to be technically successful. It's another thing to be technically and politically successful. And I think we've been able to accomplish that goal fairly readily. Next slide. And finally, a little bit about the lingo, and I touched on this. OnGo is a brand name. So OnGo is the description of using LTE, 5G NR in the CBRS band. So OnGo is a nice shorthand, simple branding for that. Instead of saying LTE and 5G NR in the CBRS band, you can just say OnGo. And OnGo is really about supporting the 3GPP technologies in the CBRS band. CBRS Alliance, of course, that's our industry association. You can always, when you talk to me, I am the executive director of the CBRS Alliance, but we support the OnGo brand. And then finally, CBRS as a term is really about the band itself. And this is the language that's used in the FCC, both the CFRs, the rulings, et cetera. Next slide. Well, with that, it's my privilege to hand over to my good friend, Mark Gibson. Mark, please take it away.
Thanks, Alan, and thanks for that kind introduction. So it's great to be here today with everybody. What I'm going to do is kind of give sort of a little bit of update on the auction, as Alan referred to, talk a little bit about what some of the prognostications have been for the band, some of the updates, and a little bit about use cases, and this will segue into Preston's discussion about Google's use for the band. So next slide, please. So it's been all in the papers, but the gross proceeds from the auction were a little bit south of 4.6 billion. And what you see there is a map that comes out of one of our tools called Spectrum Atlas, which shows the spectrum depth for the whole auction from 10 megahertz to 70 megahertz by county. And obviously you can't see, drill in on all of it, but you can see that a majority of the country was sold. In fact, of the 23,331 licenses that were available, 20,625 were sold in 2,946 counties of 3,233 counties. So it was a successful auction by all accounts. And in fact, I just read an article today or yesterday, some of those that are estimating the amount to be bid for the C block auction, which is the band right above this, have upped their bids based on the success of this auction. Early estimates for this auction were somewhere between 2.1 and I saw some as high as 6 billion, but it came in at the high end. So I think from all accounts, this was a successful auction, not so much as proceeds, but also in the varied amount of people who won. The top bidder was, in terms of the number of licenses won, was Dish. Dish ended up winning about 50-some hundred licenses. Actually, it was about 5,492 licenses, and they paid about 912 million. Next behind them in terms of licenses won was Verizon with 557 licenses, but 1.8 billion was spent. So they spent a lot for the licenses. And if you look at the markets that they won, there are a lot of the urban markets. Licenses not sold was about 287 counties, a total of about 206 licenses. Those are licenses that the FCC is going to hold. They'll probably re-auction them sometime in the future. That remains to be seen. It was roughly in the middle of the dollar per megahertz pop range, about 21.7 cents. That's right around what the estimates were. It varied a lot. There was one county that went for, I think it was $100 per megahertz pop. The county that everybody loves to talk about is Loving County, Texas, which is roughly halfway between Midland, Odessa, and El Paso, kind of almost literally in the middle of nowhere. Not that Texas is nowhere, because that's where my wife is from, but mostly just there's not much people there. I think the population for that county is roughly 82, hence the high megahertz or dollar per megahertz pop. So a lot of the interest there seemed to have been petroleum related, so that was very interesting. Down payment or final payments were made September 17th, so about 2 weeks ago. Final payments are due this week, actually day after tomorrow, not 2021. I noticed that's a mistake. It's 2020, so next week. And then licenses will propose their preferences for the channels they want, and SASs will work that out. We'll talk about that maybe some other time. So that's a real basic background on how the auction went. Again, from all accounts, it was pretty successful. So next slide, please. So mobile experts have been looking at this spectrum for a while and have been working with the CBRS Alliance. A couple of the folks from there, Joe and Kayun, both have done a lot of presentations to the CBRS Alliance plenary meetings, talking about, in fact, they did one of the early estimates for the auction proceeds. So they did this estimate for market size. I believe this is about a year or so old, so it's fairly new. They haven't updated it since the auction. But if you look at where we are in 2020, the primary contribution to the market is fixed wireless broadband. And that's pretty consistent with what's going on right now, which is most of the efforts right now are transitioning out of the Part 90 grandfather wireless broadband to Part 96, which is CBRS. And of the many tens of thousands of CBSDs deployed so far, 80% of them are probably related to that transition. As we move into the latter years, that transition have been affected, and so the contribution to fixed wireless broadband will be roughly the same as we go into the out years. But then we'll see more of a contribution on the private LTE and neutral host, as well as the mobile broadband. And both of those two are use cases that are really nicely suited for CBRS, largely because of just the spectrum ownership or spectrum leasing opportunities. So by the time we get to 2024, we'll see a larger percentage of mobile broadband applications, and then roughly equal percentages of private neutral host and fixed wireless broadband. And that fixed wireless broadband will be the transitions from the Part 90 to Part 96. Yeah, it's Kayun Moon and Joe I can't remember Joe's last name to save my life. If you could put it in the chat, that'd be great. Maybe you did. Joe Madden, thank you. So anyhow, that's it. I'm sorry, Joe. That's basically what the predictions have been. But the one key use case that we are really are focusing on, I think, as an industry, is private LTE neutral host. This is something that CBRS really enables by virtue of your ownership of the spectrum, either directly or through leasing. And so we'll talk a little bit about that as I get into the last slide. If you go to the next slide, please, that'll kind of give us the obligatory CBRS system architecture. And I won't dwell on this. Many people have seen this many times. This is our take on it. But you see in the left side, the sensor network and the core. The sensor network basically interacts with the core. When there's a trigger of basically a sensor identifies a radar operation, it tells the core. The core can discern from the information from the sensor where the sensor is located, and that tells us how we manage the devices. That information is sent to the SAS, and then the SAS does all the management. Devices will register on the SAS. That's the first step. And then almost immediately after that, upon registration, devices will ask for spectrum. And then once the devices get a list of spectrum that's available, they pick what spectrum they want, they tell the SAS, and then for all intents and purposes, they can operate on that spectrum happily, probably with no problems, unless they run in, they get some triggers from the sensors. The other thing that devices have to do, which is kind of unique to this band, is they do what's called heartbeat. Sensors send a message to the SAS roughly every 5 minutes, letting the SAS know that they're out there and still functioning. And there's things that the SAS will do if the heartbeat goes away. But that's basically how the SAS manages these devices in the context of radar systems that can operate at any time. The SAS will also manage the devices as it relates to the other two incumbents, which is the fixed satellite operators and then the grandfather wireless broadband. The grandfather wireless broadband will be gone by 2023, so that won't have to happen, but we'll still be sharing spectrum with the fixed satellite operators for a while, and the SAS will manage all of that. The other thing the SAS manages, as you heard Alan say earlier, there's this tiered operation. The top of the tier is the incumbents. The middle tier is the PALs, the priority access licensees. And the PAL auctions just completed about a month ago. And so the SAS will manage the interaction between the lower layer, which is general authorized access, and the PALs, and also among the GAA. One common, I guess, misconception of the GAA is that it's unlicensed, and in fact, it's not. While GAA don't get any protection on interference, the SAS will manage them to help effectuate coexistence and to ensure as much as possible that they get the grants they're looking for. So, but in a truly unlicensed world, you sort of fend for yourself. So that's basically how the CBRS system architecture works, and we've been doing this now since ICD began roughly a year ago. So we've been at this now in some commercial or loose commercial operation for about a year, and it's working just fine. A lot of lessons learned. We'll talk about that probably in another session, but it's been working great. So next slide, please. And then finally, at least for my deck, here are just a few use cases that we have been seeing. Another part of our company is Ruckus. We acquired Ruckus last year. CommScope acquired Ruckus last year, and we integrated them into our portfolio. And so we have truly end-to-end offering. And here's some of the things that we're seeing in terms of applications. And so I mentioned fixed wireless broadband. We have the obligatory picture of a nice farm in the middle of urban or rural areas. Fixed wireless broadband could also be happening in urban downtown areas, although a lot of these operations are occurring in lightly populated areas. So fixed wireless broadband. Then there's mobile capacity augmentation, which is basically just augmenting the additional mobile capacity that we have right now. Could be for supplemental downlink, for other TDD type operations, but we're seeing that happen, albeit lightly right now. But mobile capacity augmentation is certainly one of the use cases that we'll probably see more of as more handsets come online. The other thing is the alternative footprint. You see a picture here of a strand-mounted CBSD for cable. The cable operators and MVNOs have really looked at this band as a way to augment their coverage. And when you consider three of the main cable companies, Cox, Charter, and Comcast, all were top bidders in the auction. They really see this as an opportunity to take advantage of this spectrum to increase their footprint. And we're seeing a lot of applications there. So that's the service provider approach. The other thing the band gives opportunity to is enterprises and mobile service providers as well. And again, I mentioned private LTE, running the gamut everywhere from, for example, order fulfillment for things like Amazon or other big warehouses, or manufacturing, Internet of Things, or industrial Internet of Things around, say, process management, things like refineries and even the docks. I saw a fascinating presentation last year from somebody that was using it at the Port of LA to manage big cranes as they move across there. So that's actually pretty cool when you consider the critical infrastructure aspect of that. So private LTE is one of the new opportunities that CBRS unlocks, and we're seeing just a lot of activity around that right now, a lot of interest from many, many corners. And then finally, but certainly last but not least, the in-building cellular, or just the in-building. This is one of the areas that seems to be slightly arcane. How does this work in building, especially when you consider building loss? And again, that might be the subject of another deep dive. But the in-building operators and the in-building users are seeing this really to help augment the in-building coverage that you might get from unlicensed applications and others. So we're seeing a lot of uptake in places like multi-dwelling units, hospitality, healthcare, and those types of things that are really looking at CBRS as to adding and augmenting the coverage that they have. So with that, I'll transition over to Preston, and we'll talk about Google's interests.
Well, thank you, Mark and Alan. My name is Preston Marshall. I am Engineering Director at Google, and I've been leading our CBRS standards and technologies development work. Next slide, please. So you might ask, why is Google involved in something that's so much inside of telco systems? And it's a simple reason. It's all about bandwidth abundance. Google believes bandwidth abundance is really critical to the success of our whole society. It impacts everything we do: education, social, commerce, and it's an enabler of innovation. We've seen during this COVID incident how important broadband is to so many communities, particularly education, and the very, very deleterious effects of people lacking that broadband access, particularly during this incident. So when we think about broadband, we're not just thinking about cellular, we're thinking about mobile certainly, but also fixed wireless, and the growing use of things everywhere and anywhere. Google has an image of future ambient compute surrounded by things that compute. Google Assistant, Google Nest products, but all of those are dependent on bandwidth. And so we support CBRS because we see it as a unique ability to bring solutions to many of these problems, to broaden the number of participants in the broadband supply community, to find new ways for people to leverage their existing assets to provide broadband, and ultimately to fundamentally change bandwidth availability for large segments of the US population and industry. Next slide. So what makes CBRS such a great opportunity for bandwidth abundance? First, you have available a high-performance infrastructure and a supply chain, all available. It was developed, supported by the cellular industry. The 4G is mature and the 5G is maturing rapidly. It's available to you. It's in this band. You can buy it off the shelf. And you can build ideas and deploy them very rapidly without having to develop your own unique proprietary hardware, like most of the other bands that have been made available to non-carriers. It offers you the opportunity to have seamless access to handsets using the same technology that the handsets were built for. So whether you're a private LTE or a public LTE, the handset operates the same. It doesn't require passwords. It doesn't require changing modes. It just operates seamlessly, like handover between two carriers when roaming. And then there's a wide range of deployment and service options in this band. If you look at spectrum, traditionally spectrum has been dedicated to a use: mobility, fixed wireless, private industry. In CBRS, we have a band that supports all of those usages. And that's really important because it creates a larger supply chain, it creates the benefits of volume, it creates more innovation coming into the band, which brings down costs and adds capability. Does that all because we built a band that isn't tailored for any one community. It's certainly MNO, as Mark mentioned, MNO and MVNO service and offload is a big item. It drove a lot of the auction investment. And it's the reason that we have handsets in this band was to support the mobile operators. But along with that, the opportunity to build your own network, perhaps sell it back to carriers as neutral host, much like you service DAS in a building today. Today, we're really excited, along with Mark and all of CBRS Alliance, about the opportunities for private LTE, where essentially you build your own cellular network within your campus, within your building, and operate that, and then roam on to the more traditional operators as you leave that enterprise. And we want to, in CBRS, work to make this use case seamless. Fixed broadband's been our first deployment mode. So in an urban area, you might imagine this spectrum is heavily used for mobile outdoors. It's private LTE inside buildings, and just outside of that city, it's operating fixed broadband. So we're making use of this spectrum throughout the country. And then, although these are discrete options, there's hybrids of all of them. For example, a fixed broadband network that today can only service customer premise equipment can also service handsets using the 5G, 4G, and 5G technologies that we are advertising or we're working and advocating on Go. So it's a really unique opportunity to put together mix and match technology, services, and markets in ways that was never possible in the past. Next slide, please. So we should think a little bit about spectrum and its role in innovation. If you think about the normal process we've used for spectrum, we think of spectrum as for radios. You provide spectrum and radios use it. You should look at CBRS differently. We are providing spectrum and innovators can use it. It can enable innovation in a way that hasn't been possible in other bands, largely because we found a path that allows for scalable growth. You can start small and you can grow. You can grow in size, more bandwidth. You can grow in geographic scope. You can grow in the depth of services. So if you think about the venture ecosystem that has made so much economic activity in the United States, it was all based on small companies trying out an idea and then going big. Even Google started out with an equipment rack in someone's dorm room. So to have that ability to grow, start small and grow is really pivotal to our innovation engine. And spectrum's been an obstacle because you can't start out an idea and put down billions of dollars of investment in spectrum. Mark mentioned how much just the limited PALs cost Dish and Verizon. So having available the ability to get to spectrum and use it on any scale is really critical. Also, we don't want people to face a 5-year process of developing their technology, getting it manufactured and getting it brought in and deployed. There's a supply chain already to go in this band. And that's really why we made OnGo, was to help people utilize that supply chain. And on day one, you have access to hundreds and millions of handsets at the onset. So it's a really unique opportunity, not just to do the use cases that Mark and I have laid out, but to create your own, to try some things, to try new markets and innovate in this band in a way you never could before. And you could think of this as really how the internet grew up, because what did the internet and cloud computing do? It gave people scalability. They could start a company. They didn't have to build a whole telecom network. They didn't have to go buy thousands of computers. They could buy it, scale it, work it out, and if it grew, they grow with it. If it didn't grow, fail fast, move on, do something else. So it's really important to create this innovation engine, and we think we've done that with CBRS. Next slide, please. So it's not all roses, and it's not all done. And if you're interested in this band, you need to come and be part of meeting the remaining challenges. We still need to work on how we create seamless roaming and authentication across operators between an MNO and MVNO network and a private and neutral host network. The business models are still evolving. Who pays for what? How much do they pay? What are the methods of managing these transactions? These are still evolving. We have two working groups very, very active in working out these mechanisms. We need to do coexistence in a shared band. Part of the reason why it's important industry work together is that the 3GPP technologies are not inherently coexistence based, and so they have to be managed. You get great benefits from management and capability and capacity, but it does say we have to approach this band as a common industry. And lastly, we just are waiting as we get more and more band 48 and N48 support in new phones. I'm proud to say the Google Pixel was the first to support band 48, but now all of the Apple phones support it, most of the Samsung phones, and so we're rapidly seeing the take up of band 48 support, so you can use CBRS and talk directly to the handsets. Next slide, please. So, we are here at CBRS Alliance because we really think it's important that the industry look at this opportunity in a very integrated way. We don't want to see 1,000 proprietary standards. We want to see industry-wide ones that make the supply chain and the ecosystem available to everybody. We want to ensure they're scalable, that they're interoperable, and they're accessible, reflect a wide range of stakeholder communities. And ultimately, we want to build in CBRS a foundation for more flexible access to both technologies and spectrum. And we think we are on a good path to this. There are way too many stovepipes that segregate the wireless communities, technologies, and spectrum. And CBRS Alliance is very unique in that we have a very large number of these communities all working on the common problem of making CBRS work. And we hope ultimately that the future for spectrum looks a lot more like CBRS than some of the more traditional and exclusive models. I think that's it.
All right, gentlemen, fascinating stuff. Greatly appreciated. Some good insights. One of the things that's occurred to me as we've talked is from both of you, what do you feel is the biggest surprise you've observed in this 5 months since we turned on the lights? What has been the thing that really stands out in your minds? And Press, maybe start with you, and then we'll go over to Mark.
Yes, I think there's two things actually. One is how rapidly people have started using the band, despite all the obstacles that COVID has put in the way. I was really concerned when we got turned on, and we got turned on about the same time the country got turned off. And yet we've still seen a very large amount. And we're seeing some incredible performance numbers from the people who have deployed, particularly the modern 5G-based equipment. It's an order of magnitude improvement over the technologies that are being supplanted by CBRS. And I think the second one is how much interest there's been in private LTE. It takes considerable imagination for people to consider themselves as cellular suppliers. That's quite a leap. And yet we're seeing conferences like this and others all over helping people along that process of going from running more traditional networks to actually stepping forward and embracing the idea that the cellular technology and CBRS offers some unique capabilities within their company. And we saw that. We saw the biggest, the most expensive auction was actually to a utility company who saw it for Internet of Things usage. Everyone was shocked at this because, my gosh, it's so much megahertz per pop. But if you think about an energy company, maybe it's megahertz, it's dollars per megahertz joule in the ground. We have to think about different measures because we see these new people coming forward into the band.
Interesting. Mark?
For me, like Preston, we've been down and dirty in this since the beginning, so very little surprises us now. But for me, it was the auction. I agree with everything Preston said. Those were kind of gentle surprises, but for me, the auction was really a pleasant surprise. I mean, I didn't think he would come in at 4.6 billion, and I was watching that thing on a per round basis just because people kept asking me questions about how it was going. And so there was one thing. The other thing was not just the actual auction running it, but the activity beforehand. I mean, there were 270 companies or entities that applied to bid, which is more than in any other auction the commission's had so far. So that says that in spite of the fact that well, I shouldn't say in spite of, the fact that we went to counties, to try to sort of find a middle ground between the larger market areas and the smaller market areas, the PEAs and census tracts, it still invited a lot of very diverse companies. I mean, looking at the auction proceeds, like I think I said this, 86%, almost 87% or 88% actually of the auction monies went to 5-6 companies. So that means of the 240 some winners, the remaining auction proceeds were split among them in terms of monies. And there's people that got licenses for as little as $1,100 bucks. So, and I think that's probably the cheapest paid for a license actually so far in all the auctions. And so I think you can look at I've said this before, although I'm the only one that said this. I look at the CBRS band as the people's band. It really is. I mean, you've got WISPs that have participated, utilities that have participated, and these are entities that have traditionally not really been owners of spectrum. And I think that's what this auction has done for them. We knew that, we thought that would happen. We obviously thought that would be the case when we saw the bidders, but it actually came through. And so that kind of was a surprise. We all wanted it to happen, but to see it happen, in such a good sense. And so for me, I think it was really just the auction and the success of that. And then everything press said.
Interesting. Yeah, so I think.
Can I just come back on that one in a second? You have to think back. It doesn't sound so shocking now how successful this has been, but if you went back to 2012 when this was a report to the Obama administration on a path forward for the National Broadband Plan, really, the entire world lined up against this idea of 3-tier spectrum. It was useless. It was wasted spectrum. No one would want it. So we've done a lot to come forward technically to put together all the standards, but look at how those attitudes changed. One of the operators whose industry group said, no, this is useless and wasted, was actually the biggest bidder in the auctions that Mark just talked about. Yep. So in addition to all the technical work we've done, we've also done a lot to convince people that these new models have unique opportunities that even introduce options for very traditional players. Mm. And so I think there's been a lot of, I would say, education and mind opening that's gone on along with all the technical progress that's easier to point to.
Got it.
And I would say, just to add to that, and Press and I are both SaaS providers, the SaaS. Now for me, and I'm sure for Press too, it's not a surprise that SaaS works. I think I was surprised that so many people felt like it wouldn't. And maybe that's just sort of building off of the lackluster efforts, or not efforts, but success for TV Whitespace. And while the SaaS adds complexity, that's all behind the scenes. And so I think the fact that we now have, considering, when we started ICD in September last year to now, a year worth of SaaS operations with no major hiccups, especially with respect to interference potential into military radars, I'd say we can say that the SaaS has been successful. And while that's not a surprise to either of us, I think that might come as a surprise to some folks in the industry.
It certainly wasn't what they expected, Alan. We're never going to let you get a question in, but realize that we did 2 leaps at once.
Yeah.
First, we built a SaaS at all, and secondly, we made it competitive.
Yeah.
Almost everybody started out saying, well, it's going to be so hard to do, only one company can do it. And so CommScope, ourselves, federated initially, said, this doesn't work if one guy does it. Yeah. No one's going to have faith in one guy. We anti-competitive. So we actually did 2 leaps. We got a SaaS to work, and then we created a competitive ecosystem of SaaS suppliers that gives people options and comfort that there'll be a SaaS provider and that there'll be competition in terms of quality and cost. We sort of made 2 leaps in one. Right. That second one was aggressive, and it works. Every night our SaaSes get together and they coordinate, and no one makes phone calls at 2 in the morning to me to tell me it didn't work.
It didn't work.